Hi all the students. Today we are going to discuss the design issues for layers. Now in our previous video we have seen how a network is divided into different layers. That is why the network that we use has a layered architecture. Now we will see what all design issues are there for the layers. That is, while designing, what all things or what all issues must be what all things must be taken care of. What are the issues that must be given priority while designing the layers? So out of these, there are 4 or 5 issues which are very important. One is your addressing. Then is your set of rules for data transfer, or you can say rules for data transfer. Then the third important issue is error control. Then is your flow control. The fifth issue is multiplexing. And the sixth issue is routing. All these issues we will study today, but the details, we will not go into the details. Today we will just have a brief idea of all these issues, and later in our upcoming videos we will study all these issues in detail. So let's begin with the first issue, that is addressing. What is addressing? So basically what happens is that every layer needs to identify the senders and receiver. You need to identify the senders who will be sending the messages and receivers who will be receiving the messages in the network, right? So since there are multiple destinations, there is not just one sender and there is not just one receiver. You have multiple destinations or multiple receivers. Now because of this, some form of addressing is needed, right? Some form of addressing is needed, because if there are multiple receivers or multiple destinations, then if the packet or the message travels through the network, then how do we know that for which particular destination this message is intended? This is done with the help of addressing to specify the specific, which specific destination this message is intended for out of the several destinations that we have. Just like a postman, when you send a letter, you write the address on the letter. A postman has so many addresses where he has to deliver the letters. Now how does he identify which letter is intended for which particular destination? Through the address on the envelope. So similarly, this is how addressing in networking also helps to identify that out of so many receivers, out of so many destinations or receivers that we have, this particular message is intended for which receiver. So this is addressing one issue. Then the another issue is rules for data transfer. Now what is this issue? In here we see the set of decisions that which concern the rules for data transfer, right? So the name itself says rules for data transfer. That means we are concerned about the decisions about the rules for data transfer. Like in some systems, in some systems data travels in only one direction, while in other systems the data travels in both directions. When I say that the data travels in only one direction, that means the sender can only send the data and the receiver can only receive the data. When I say that data travels in both directions, that means the sender can both send as well as receive the data and the receiver can also receive as well as send the data. So this means data travels in both directions. Now, how many channels the connection can handle at any point of time? What do you mean by channel? When I say, so this particular design issue, that setting the rules for data transfer, is concerned with determining how many channels or logical channels the connection, how many logical channels that the connection can correspond to at any given point of time, and also what are their priorities. What are the priorities of those channels? Because if one connection is having more than one channel or more than one transmission line, so how many first of all, how many channels or transmission lines that particular connection can have? And then secondly, what would be the priorities of those channels or transmission lines? That means while the connection wants to transmit data, which particular channel will it be using for the transmission of data, right? Now, in most of the cases, many networks provide, there are at least 2 channels. At least means minimum, there are, in most of the networks, there are at least 2 channels provided with each connection, right? So, out of these 2 channels, one channel is mostly used for normal data, and other channel is used for urgent data. So when the data is urgent, then the channel which is meant for the urgent data is used, and when the data is normal, that is, it is not that urgent or it is not a real-time data, then the channel meant for the normal data is used. Now the third issue is your error control. Now, what is error control? This is yet another important issue because the physical communication circuits are not perfect. While you are using the physical channels or physical transmission lines for data, they are prone to errors. So I can say that the physical communication circuits are prone to errors. So what do I do in this case? I need some sort of error correcting and error detecting techniques, right? So while the data is sent, I must have some techniques for detecting the errors first of all, and if in case an error has been detected, then I must have some mechanism for correcting those errors also. But here the issue is that both the ends, that is the sender as well as the receiver, must agree on the same method, of error correcting and error detecting, because there are several methods which we will study in detail later, several methods for error detecting and several methods for error correcting. Which one method would be used for error detecting and which one method would be used for error correcting, both of these senders and receiver must agree upon the same method. So this is also yet another important issue. Also, the receiver must have some way of telling the sender that which all messages have been correctly received, which messages have been correctly received, and which all messages have not been correctly received. So these are the issues related to error control in a layer. Now next is your flow control. The next design issue that we will talk of is the flow control. It is concerned with controlling the flow of the data. Now there is a possibility when there is a sender and a receiver. The sender is fast but the receiver is slow, right? Say, take an example where, say, there is a teacher and a student. Now the speed at which the teacher explains is very fast and the speed at which a student can actually understand it is very slow. So if I talk very fast and you are not able to understand at that pace, that means whatever has been taught will be wasted because you will not be able to get anything in your head. So what do I need to do? I should teach you at the pace at which you can understand. You are the receiver and I am the sender. So I will slow down my speed at a pace at which you can understand. Similarly, when there is a sender who is fast, that means the rate at which the sender transmits the data is much higher than the rate at which the receiver can receive data. So that means the receiver is slow but the sender is fast. So when the sender is sending messages at a faster pace then at the pace at which the receiver can receive it, most of the messages will be lost. Just like whatever I teach you will be lost. That information will be lost and not retained if I do not teach you at the speed at which you can understand. Similarly, if the sender does not send the data at a speed which the receiver can handle it or at a speed at which the receiver can receive it, most of the messages will be lost. So to avoid this situation, we need to have a mechanism known as flow control. Now this also we will study in detail later, but as of now there are certain mechanisms, like first of all, you get some kind of feedback, right? The sender gets a feedback from the receiver that okay, I am not able to handle the rate at which you are sending the messages. So in this case, the sender slows its speed. Just like when I receive a feedback from you that ma'am, we have not understood what you've taught, I will repeat it for you, or I will explain it in a slower pace. So similarly, the receiver sends a feedback to the sender, and the sender now understands that it has to slow down its speed. It has to send the messages at a comparatively slower speed, right? This is one mechanism. Then another mechanism is that limit the sender to an agreed on transmission rate. One is you get the feedback from the receiver and then you slow down your speed, and the other is that you there is an agreed on transmission rate. Agreed on transmission rate, there is in advance it is fixed that at this rate the data will be sent, like 1 packet in 10 seconds. This is the speed for all the packets. So even if 1 packet has been sent in this time, no more packet will be sent unless 10 seconds are over. Just like we agree on a particular chapter in a day, like we agree that okay, no more than 1 page in a day we will study. So we've agreed on the transmission rate that 1 page in a day I will teach you. This is one method. Another is feedback, that I may teach you as many pages in a day, but it depends upon your feedback. If you say you've able to understand, I will continue. If you say you've not been able to understand, I will repeat that for you. So similarly is the case with the sender and receiver in a computer network. One method is feedback, wherein the sender knows from the receiver that it is not able to handle this rate at which it is sending the messages, so it will slow down its speed. And another is at the beginning only they agree upon a certain transmission rate, and then the data packets will be sent at that particular speed or rate only. Now next is your multiplexing. Next design issue is multiplexing. Now multiplexing is basically collecting or when it is inconvenient or expensive to set up a separate connection for each pair of communicating processes. Now there are many senders and many receivers. Now, instead, say sender 1, receiver 1, sender 2, receiver 2, sender 3, receiver 3. Now, instead of setting up a separate connection for each pair of communicating processes. Now S1 and R1 are one pair of communicating processes, S2 and R2 are another pair of communicating processes, and S3 and R3 are another pair of communicating processes. So these are different pairs of communicating processes. So in general what happens is that I set up a separate connection for all these three pair of communicating processes. Say connection 1 for S1 and R1, then connection 2 for S2 and R2, and connection 3 for S3 and R3. In general, this is what happens, that you set up separate connections for separate pair of communicating processes. But when it is inconvenient or it is expensive to set up a separate connection for each pair of communicating processes, then the underlying layer may decide to use the same connection. Instead of using 3 separate connections for 3 separate pairs of communicating processes, the underlying layer decides that okay, it will use only one connection for all these 3 pairs of communicating processes. So this is known as your multiplexing. Then the last design issue that we will be talking of in today's video is your routing. Now routing, I have told you earlier also, routing is basically done by routers. Routers are special computers or specialized computers that receive data from an incoming line or incoming transmission line and then decide from which outgoing line the data will be sent. So this is known as routing. That if I have a router R1 and there is a transmission line that brings a data packet P1 to R1, and from R1 there are 3 outgoing transmission lines. So the router R1 will first of all receive a data packet from an incoming transmission line. Then after receiving data from this incoming transmission line, out of these 3 outgoing transmission lines, router R1 will decide that which particular transmission line it will choose to transmit the data, whether it will choose line 1 or line 2 or line 3. So this is known as routing, that the routers receive data from an incoming line and then they decide from which outgoing line data will be sent. So this is routing. So these are all the design issues that are very important while designing the layers, and they must be given priority so that there are no problems later on.